Greetings, Houdini Python students. In this lesson, we are going to be exploring the Python SOP. The Python SOP is probably the most basic Python operator. The format and template established by the Python SOP lays the foundation for all the other Python operators you may want to create. But before we create a custom Python SOP, we need to dedicate a session on their mechanics. As a disclaimer, Luke Moore wanted me to remind you students that a major of the strength of Houdini is in its nodes and its ability to connect them together. Where possible, it's best to create digital assets of subnets of SOPs and use Python and HDK whenever that's not possible. It's not unusual, though, that the Python operator is actually slower than a node network. Similarly, if you want to run a script whenever the node cooks, you might have better luck with a script SOP. A Python SOP is only used for creating and modifying geometry using Python within a SOP. With that said, let's start with a fresh Houdini session and create a Python SOP. So I'm going to go ahead and grab a new session. I'm going to discard the old. All right, we're going to zoom right in here. I'm going to go create file, new operator type. All right, we've got our operator type window. I'm going to create a new name called preview SOP. Preview SOP, and let's call this preview SOP. All right, now we have to choose the operator style, and for this we're going to choose the Python type, which tells us that we are going to be creating a Python SOP. Now for the network type, we're going to scroll down here, then we see we've got all these various operator types. We've got our operators, we've got our geometry operators, which are SOPs, compositing operators, which are our COPs, and dynamics operators, which are our DOPs. We're going to choose geometry operator for our SOPs. Now we have to save to a library. Now I'm going to choose my typical location where I'm saving all of my digital tutors information. All right, and I'm going to call this, make sure it's called, I'm going to make sure that it's called preview SOP. Preview SOP. Oh, that's a SOP. Okay, great. And then I'm going to click accept. All right. Now we have to. Now there's a lot of debate out there whether you should save your OTLs out to individual libraries or as individual files. I, however, found that it's best to that each digital asset be contained within its own library. Now we want to install it in the current HIP file, and we're going to hit accept. Okay, then we have our good old type properties window. And now we're ready to rock and roll. Okay, for all intents and purposes, there's very little difference between a Python SOP and your standard HDA. Now, the major difference is that the default Python code is executed for the code tab and not from the scripts. As you can see here, we've got some information for code. You won't find this in an HDA. Other than that, all the rules used during your prior HDA examples will apply here. So as a review, you can only start modifying geometry by accessing an object's geometry node. Houdini has already done this step for you. You see here it's identified the who.pwd and it assigned this to a node variable. It took that node variable, grabbed its geometry, and assigned it to a geo variable. So let's go ahead and start creating some geometry. I'm going to create a basic quad, and the command for that is geo.createPolygon. Now we saw create polygon before. Now from this polygon we are going to iterate on 4 quadrant positions, and we are going to create points and vertices corresponding to each one of those points. So here we have the 4 corners around 1, 1, and -1. Now we're going to start iterating around those, and we're going to start creating points, and we're going to start creating vertices. So the first step on this is to go ahead. Hello, come on, give it to me, come on. All right, now we're going to create a point. Then we are going to take that point, and then we are going to set its position based on the position of the variable that we're iterating on. Point.setPosition pause. Pause is the variable that we're iterating on. And then we're going to take that quad, and then we're going to add a vertex to it. And that vertex is the point variable that we just created. Okay, now let's add a new, let's add a, I'm going to go ahead and apply this. We should be good to go. Now let's add a new operator type for this. We have a blank window. So I'm going to say tab, add. So I'm going to actually have to go into the, create a geometry window. So I'm going to go geometry. Okay, we're Geo1. Okay, now we're in the geometry operator. And we want to get rid of this block. So I'm going to hit tab, is a digital assets, and we have our preview SOP. Okay, it looks like we have an error. Now, I'm going to middle mouse click that, and if you can see this in the window, we notice that the error says that there's not enough sources specified. Actually, that is easy enough to fix. We can go to our type properties window and then go to the basics, and then for the minimum number of inputs, we're just going to slide that over to 0. And I'm going to click accept, and then the problem went away, our error went away, and we see now that we have a nice little quad in the center of our world. Okay, to make things a bit more interesting, let's control the color of this quad with a color chooser. Now I'm going to go back to my type properties window, and I'm going to go over here to the parameters. Now I'm going to grab a color chooser from the widget bin, and I'm going to drag it over to root, drop it in there, and I'm going to call this guy color. All right, now I'm going to go back to the code, and now we're going to tell what to do with that color information. First, we're going to go and grab all of the color information from the actual parm. So what that is now, it's no longer a widget, it's actually a parm generator. Now that's one way of thinking about it. But we see here color R now equals the node and its parm, and it has a new parm called color. And it's got 3 components, color R, G, and B. And we want to grab each one of those parms and we want to evaluate it. We don't actually want the parm, we want the parm's evaluation. I'm going to go ahead and do this for G and B. Color G and color B. All right, very good. Now all we have to do is add a simple primitive color attribute, and we're going to insert these components into that, and we should be ready to go. Hold on a second. And so where are we going? Okay. Okay, geo.add attribute, and so that's the method is add attribute. Who.attrib type prim, CD is the color, then we're looking for color R, color G, and we're missing color B. All right. And then we're going to close that, and I'm going to hit apply. Okay. Now we see we have a little color swatch in our little window up there. Now when we press the color swatch, we can start choosing colors, and immediately our little quad is going to start changing colors depending on whatever we choose inside of our color window. All right, to rehash this lesson, we explored the very basics of the Python SOPs and compared them against traditional HDAs. And then we wrote a simple routine to create a quad and control its color. In the next session, we're going to create a production quality Python SOP. I'll see you in the next lesson.